Hi everyone, this is Rohan, and in this video I'm going to explain to you the types of structures occurring in practice. Come, let's learn. So, the first kind of structure occurring in practice are skeletal structures. These structures can be idealized to a series of straight lines or curved lines or a combination of straight lines and curved lines. These structures look like skeleton. That means each structural member will look like the bones of a skeleton. For example, building frames, arch bridges, roof trusses, etc. Now, let me explain this further with the help of real pictures of this example. So as you can see here, this is a building frame, and if I consider the front face, I can idealize the beams as the horizontal straight lines, right? And I can idealize the columns as vertical straight lines here. So for the analysis of the front face of this building, I can draw this structure like this. Okay, so as you can see, this is a series of horizontal as well as vertical straight lines. So this looks like, each member looks like the bones of a skeleton. So this is a skeletal structure. Similarly, if you consider this arch bridge, this arch here can be idealized to a curved line, right? The deck above can be idealized to a straight line, and each of this connecting units can be considered as the vertical straight lines. I'm not going to draw all of this, just see here. You can see that this is a curved line and a series of horizontal, vertical as well as horizontal straight lines. So this is also a skeletal structure. So the next type of structure occurring in practice are surface structure. Now these are the structure that can be idealized to a plane or a curved surface. For example, flat slab, domes, etc. Again, I will take the real pictures of the examples and explain it further to you. So if you see here the flat slab here, right? So can you idealize it to a straight line? No, you cannot. You have to idealize to a plane. So as you can see here, it is idealized to a plane, and then you can do your analysis. You can never idealize it to a straight line, right? Similarly, if you consider a dome, again you cannot idealize it to a straight line or curved line. You have to consider it as a surface. So as you can see, this is one surface from here, and you can see this is another surface line from here, right? So this you have to consider as an entire surface. This is not one curved line, this is an entire surface. So this is a surface structure. And the third kind of structure occurring in practice are solid structures. In solid structure, you can neither idealize it as a straight line or a curved line or a flat plane or a curved plane. So such kind of structures are called as solid structures. For example, dams, retaining walls, etc. So again, with the help of real images of this example, let me explain. So if you see the cross section of a dam here, again you can see we have to consider it as a whole, as a solid structure. Now you see we cannot idealize it to one line. Even if I would have just taken this part, if I would have just taken this part, then I could have called it that this is a plane. But no, I cannot do that. I have to consider the entire thing as a solid. So this is a solid structure. Similarly, in the example of retaining wall also, you can see that we have to take it as a entire solid, not as a straight line, not as a plane, so as a solid. So just to summarize this video, the types of structure occurring in practice are firstly skeletal structures, which can be idealized to either straight lines or curved lines or a combination of both. Then each structural member of the skeletal structures look like a skeleton. For example, building frames, arch bridges, roof trusses, etc. The second type is the surface structures, that is, they can be idealized to a plane or curved surface. For example, flat slab, domes, etc. And the third type is the solid structure. It can neither be idealized to a straight line or a curved line or a flat surface or a curved surface. This kind of structures are called as solid structures. For example, dams, retaining walls, etc. For the making of this video, the reference that I used is this book, Structural Analysis, a Matrix Method by G.S. Pandit and S.P. Gupta, and this is courtesy the McGraw-Hill companies. So if you have any doubts, you can write in the comments below. Thank you for your time.